So here's a second short video to talk about integer subtraction, section 1.6, and our objective is we will use models and rules to subtract integers. So we've already looked a little bit at subtraction, but let's look at another way to do it. So first of all, in order to do subtraction, we have to know the rules for addition. So when the signs are the same, think about what you do. So you've probably thought about it. You should add normally. We add normally, and we keep the sign. Then when the signs are different, we have to do what? Well, we have to subtract instead of add. We subtract the bigger from the smaller, and then we keep the sign of the bigger absolute value. Keep sign of the bigger. Now with subtraction, there's really one thing you have to remember, is that you can always turn subtraction into addition. So we've talked about how I kind of have a little conspiracy theory that subtraction really doesn't exist, because we can always make it into addition. So if we did that, subtraction is really adding the opposite. Woo, bright shining colors. Add the opposite, add the opposite. Subtraction makes us get smaller, right? Or it changes the direction that we go. So we can always change it to addition and then make the next number the opposite of what it is. To subtract an integer, we add its opposite. We still have the same rules that we had on the last one. Positive numbers make us go to the right, negative numbers make us go to the left. Subtraction makes us go to the left, which is also why we can turn numbers into negative numbers. Here's a couple examples. 3 minus 5. 3 minus 5 changes to 3 plus a negative 5. This 5 is really a negative 5. That's why a minus sign and a negative sign look the same. Then if we had negative 3 minus 5, we'd have negative 3 plus a negative 5. And that would be negative 8. There's also a few others that we're going to have to look at, like when we have something like 3 minus a negative 5. A double negative minus a minus, like you saw in one of those earlier videos, is really like saying not. So they kind of cancel each other out. But we can use our rule of adding the opposite. We add the opposite of negative 5, which is positive 5. So if you said, I'm not going to the party, you would mean you are going. So if we have 3 minus a negative 5, it's really 3 plus 5, which is 8. Let's look at a few examples here. 4 minus 6. Now some of you may be able to think about it in your head or on a number line, but let's make it add the opposite. 4 plus negative 6. We have different signs, so we are going to subtract 6 minus 4. 6 minus 4 is 2. Keep the sign of the bigger absolute value, negative 2. Now we got one of those minus a minus. Remember, that makes it plus a positive, so we need to add the opposite. The opposite of negative 15 is positive 15. Since we have different signs, we're going to subtract 32 minus 15. If you need to write it out, write it out. And we get 17. Since the negative 32 is a bigger absolute value, it's negative. Next one, 27 minus negative 13. Again, we need to add the opposite. If we have minus a minus plus the opposite of negative 13, positive 13, it's like a double negative, it makes it positive. If we had 27 and 13, we can write it out. And we get 40. And this is positive 40 because these are both positive. We have to add normally, keep the sign. I want you to pause and try these two on your own. I'm actually going to give you the answers so you just have a chance to check yourself. Okay, here are the answers. 12 plus negative 35, 35 minus 12, negative 23. For this one, we have to change it to negative 6 plus negative 11 plus 12. If we add these two, negative 17 plus 12, which equals negative 5. Here are your exit pass problems that are going to be on your guided notes and that we'll talk about tomorrow.